Well, hello and welcome back. I think you're going to like this lesson. We're on notes number 11, and today we get to review the ideas that we've learned since Algebra 1 or maybe before about the equations of lines. So this should not be too taxing on your brain, I think. I think you're going to find this familiar. So we're going to go through the main ideas and do an example of each. So let's start by talking about slope. And we know that slope is rise over run. We often use the letter M to stand for slope. And so we can think of it conceptually as rise over run. We're talking about the slope of a line here. But also if we have 2 points, x1, y1, and x2, y2, we can think of slope as the change in y, y2 minus y1, over the change in x, x2 minus x1. So that's the formula that you're probably familiar with. So let's do example 1. Find the slope of the segment joining the points -2, 7 and 4, 0. Okay, so let's say that -2, 7 is x1, y1, and 4, 0 is x2, y2. So the change in y, y2 minus y1, is going to be 0 minus 7, over the change in x, x2 minus x1 is going to be 4 minus -2. Be careful with the negative there. And then we simplify, so we have -7 over 6. And we can just call that -7/6, and that's the slope. Remember that a line with a negative slope is going to be a decreasing line. A line with a positive slope is going to be an increasing line. Okay, now let's review slope-intercept form. Slope-intercept form is when you have the equation of a line in the form y equals mx plus b. And as we saw a moment ago, m is the slope. And then we know that b is the y-coordinate of the y-intercept. Sometimes we just say b is the y-intercept. The y-intercept is the point 0, b. And remember, the y-intercept is the point where the line crosses the y-axis. So for example number 2, we're going to find the slope-intercept equation of the line through the points -2, 7 and 4, 0. And hopefully you notice that these points are the points I used in problem number 1. So we already know the slope. The slope is -7/6. Now we have to also find the value of b, because when we write the slope-intercept equation, we have to know the number to substitute in for m and the number to substitute in for b. So we already have our number for m. So let's go ahead and take one of our points, either one, doesn't matter which. I'm going to take 4, 0, since those numbers are easier to work with, and substitute those in for x and y in our equation, and we'll be able to solve for b. So if we use y equals mx plus b, substitute 0 in for y, -7/6 in for x, for m, 4 in for x, and solve for b. So let's do that. So -7/6 times 4 is going to reduce to, let's see, -14/3, right? Because we can reduce the 4 over 6 and make it 2 over 3. And then to get b by itself, we'll add 14/3 to both sides. So now we need to put it all together. So we have our equation y equals -7/6x plus 14/3. Make sure when you write the x that you don't write it way down low with the 6, because the x is not in the denominator. Okay, let's see what we have next. We have a couple other forms for the equation of the line. One is called point-slope form and the other is called standard form. And point-slope form is often used kind of in the middle of doing a problem. Point-slope form looks like this. Y minus y1 equals m times x minus x1, where x1, y1 is a point that you know and m is the slope that you know. So it's convenient to use those on a problem like number 3, where you're given the slope, 1/2, and you're given a point, 2, -3, and you're asked to find the equation. Now in this case, we're asked to find the slope-intercept equation. So in theory, we could do it the same way we did number 2, but I just want to show you an alternative. I want to show you how you would do it with point-slope form. So you're going to substitute -3 in for y1, 2 in for x1, and 1/2 in for m. So that means we have y minus -3 equals 1/2 times x minus 2. That's our point slope form with those numbers plugged in. Let's simplify it. So this is y plus 3 equals, and then we distribute 1/2 x minus 1. And then because our goal is to get slope-intercept form, we're going to subtract 3 from both sides. So we have y equals 1/2 x minus 4. We tend to prefer slope-intercept form because it's easy to tell what's going on with the line if you have the answer in that form. Now let's look at standard form. Standard form you often see when you have word problems. This is the one that looks like this: ax plus by equals c. So it's still the equation of a line as long as x is to the first power and y is to the first power, but it's just rearranged in a different way. And often some textbooks will have some restrictions about what kind of numbers you can use for a, b, and c. So I think in our book they say that a, b, and c need to be integers. And remember what integers are. These are numbers like 1, 2, 3, -1, -2, -3, 0, etc. So not fractions, not like 1/2 or 2/3 or something like that. Sometimes they also say that the first number a has to be positive, but that's not really that important to me, so I'm not going to worry about that. Okay, let's look at this example. Here's an equation that's in slope-intercept form, and we're going to convert it to standard form. So the things about standard form, in addition to having integers, is that you have to have the terms in the order: the x term, then the y term, then equals, and then the constant. So what we can do is we can subtract 1/2 x from both sides of the equation. That way the x term and the y term will be on the same side. And then to deal with the fractions, we can multiply the whole equation by 2. Or if you don't want to lead with a negative number, you could multiply the whole equation by -2. So I think I'll do that. So that's going to give us x minus 2y equals -3. So that's standard form. Okay, let's keep cruising along. Next we're going to look at horizontal lines and vertical lines, and I suspect you have a good visual for what those terms mean. Horizontal lines are constant. That's a term we used in our last lesson. So you have something that's just flat, and vertical lines look like that. Now if you think about which one of these is a function, horizontal lines do pass the vertical line test. Vertical lines do not pass the vertical line test. Vertical lines are not a function. Horizontal lines are. And anytime you have a horizontal line, every point has the same y-coordinate because every point has the same height. So the equation is always just going to look like y equals some number k, like y equals 2, y equals 3, y equals 0, something like that. And anytime you have a vertical line, every point has the same x-coordinate, so the equation is going to look like x equals some number k, x equals 2, x equals 9, something like that. Okay, so let's do number 5. Find the equation of the line through the point 3, 6 and -2, 6. Now, there's a couple of different ways we can do this. One is we can just go, oh, I know how to find the equation of the line. First I find the slope, then I find the y-intercept, then I substitute things into the equation, and that is true and that should work. However, I would recommend you actually just stop and think about this and recognize, oh, that has a y-coordinate of 6 and that has a y-coordinate of 6. They have the same y-coordinate. That means these points have the same height, and that tells me that these points fall on a horizontal line. So let's say this point here is -2, 6, and this point here is 3, 6. Well, what's the height of the line? 6. So what's the equation? Y equals 6. So you could actually do it that fast if you just notice they both have 6, it's y equals 6. If you don't notice that, then you're going to say, okay, what's the slope? y2 minus y1, 6 minus 6, over x2 minus x1, -2 minus 3. We get 0 over -5. The slope is 0. By the way, horizontal lines, excuse me, always have a slope of 0. And vertical lines, the slope is always undefined, because if slope is rise over run, there's no run. There's no horizontal direction, horizontal change, I should say. Okay, so if we're back on number 5 and we get a slope of 0, and then we go, okay, that's fine. Now I'm going to use point slope form, and I'm going to find the rest of the equation. So let me plug in my point 3, 6. So my y-coordinate is 6, and my x-coordinate is 3, and I get y minus 6 equals 0, and then I add 6 to both sides, and I get y equals 6. See, that still works. Nothing wrong with that. It just is a much more lengthy way to do it. Okay, number 6. Find the equation of the line through 3, 6 and 3, 0. Okay, notice that they both have an x-coordinate of 3. And when points have the same x-coordinate, they lie on a vertical line. 3, 6, 3, 0. And what's the x-coordinate of every point? 3. So what's the equation? X equals 3. Now if you didn't stop and think about that and you just started to calculate the slope, y2 minus y1 over x2 minus x1, you're going to realize that you get an undefined slope. And by that point, you're kind of stuck, like you can't do any more algebra, but hopefully at that point you realize you do have a vertical line. Okay, we're getting there. We just have about 4 more to do. Parallel lines and perpendicular lines. So remember that parallel lines have the same slope, and they have to have different y-intercepts. If they have the same slope and the same y-intercept, they would be the same line. So parallel lines could be increasing like this, could be decreasing, they could be both horizontal, both vertical. There's all different kinds of parallel lines, but they have the same slope. Whereas perpendicular lines, if one is increasing, the other is decreasing. If one is horizontal, the other is vertical. And their slopes are opposite reciprocals. One is positive, one is negative, and then reciprocals like 1/3 and 3 over 1, 7 over 2, 2 over 7. So you have to have the opposite and the reciprocal. So, for example, 3/2 and negative 2/3 are opposite reciprocals. Okay, let's do these examples. Find the slope-intercept equation of the line through 2, 5 and parallel to y equals negative 2x plus 1. One way to approach this would be to start by graphing. You can graph the line you're given, you can plot the point you're given, and you can visualize the situation. That's a great idea. Another thing to do is remember that parallel lines have the same slope. And looking at this equation here, the slope is negative 2. So we're looking to write the equation of a line that has a slope of negative 2 and goes through the point 2, 5. Well, if you have the slope and you have a point, might as well use point-slope form. So let's substitute 5 in for the y1, negative 2 in for the slope, and 2 in for the x1, and simplify. So y minus 5 equals negative 2x plus 4. Add 5 to both sides, y equals negative 2x plus 9. So that line is parallel to the other line. And if you look back at the other equation, it kind of makes sense. Like you have y equals negative 2x plus something, and y equals negative 2x plus something else. It makes sense that those are parallel. We just didn't know what that number would be until we worked it out. Okay, number 8. Find the standard form equation of the line through 1, negative 3 and perpendicular to the given line. So we know that perpendicular lines have opposite reciprocal slopes. We have to figure out the slope of this given line, and then we'll find its opposite reciprocal. So take the given line and change it to slope-intercept form so that you can find its slope. So subtract 2x from both sides, and then divide both sides by negative 3. So now we see the slope of the given line is 2/3. We need the opposite reciprocal, so the perpendicular slope is going to be negative 3/2. Now that we have that and we have a point, we can use point-slope form again, or you can use y equals mx plus b. You'll get the same answer either way. Let's substitute negative 3 in for our y1. We have negative 3/2 for our slope. We have 1 for our x1. So we have y plus 3 equals negative 3/2 x plus 3/2. And then we'll subtract 3 from both sides. So y equals negative 3/2 x minus 3/2. And it certainly would not be a bad idea to just graph both of those lines and make sure that they do look perpendicular. Of course, because my video, I'm trying to keep the length down as much as possible, I'm not going to do that step. Okay, getting near the end here, we're going to do a little bit of graphing. Oh, uh-oh. You know, you should never trust math teachers who use graph paper, right? They're always plotting something. Okay, graph the line f of x equals 2x minus 3. Notice I'm using function notation. That was one of the things that was brought up yesterday. It's the same thing as y equals 2x minus 3. F of x is being used instead of y. So what we can tell is that the slope is 2, and the y-intercept has a y-coordinate of negative 3. And I'm going to choose to go by ones on my graph here. Always indicate your scale. If you're not going by ones, or if you are, always make a note of what your scale is. And so then let's start by plotting the y-intercept at 0, negative 3. And then from there, because the slope is 2, I'm going to go up 2 and over 1, up 2 and over 1, etc. as many times as you want to get enough points. And then we'll just sketch the line. Sorry, mine's not very straight. I don't have a ruler for that. Okay, now suppose you want to graph a line and your equation is in standard form. Well, you have some options. You could just rearrange it into slope-intercept form if you want, or you can just leave it in standard form and find its intercepts, and that's my preference. So suppose x is 0. If x is 0, then y would have to be negative 3 if you just use the equation to figure that out. And suppose y is 0. If y is 0, then x would have to be 4. So this gives us a couple of points we can plot. Once again, I think I'll just go by ones. So we have the point 0, negative 3. We have the point 4, 0. We can plot those 2 points and draw the line. Now, to finish off, what if we want to use our graphing calculators to graph these? So for number 9, it's really straightforward, but I'll show you how. And for number 10, well, your calculator needs you to change it into y equals mx plus b form. So what you're going to have to do is subtract 3x from both sides. You would have to do this with paper, pencil before you get started on your calculator. And then divide both sides by negative 4. And then you'll be able to type it into the calculator. So let's go ahead and grab a calculator, and let's do number 9. F of x equals 2x minus 3. So we go into the y equals menu. And if there's anything already there, then you should clear it. You can also clear your memory just in general by pressing second plus, and then number 7 reset, and then all RAM, and then number 2 reset. So that will get rid of anything that's in there, and it will set you back to your default mode, which is kind of nice. So f of x equals 2x minus 3. We just type in 2x. You see the x button up here next to the alpha button. Minus 3. And then you have to set a good window. So your calculator has some built-in windows. If you go to zoom and you try zoom standard number 6, it will show you from negative 10 to 10 on both axes. And that's a pretty good window for this particular graph. You could also try zoom 4, zoom decimal. You could try zoom 5, zoom square. You can just play around with it. And you can also go to window and you can type in your own numbers. So as long as you can see the line and you can see its x-intercept and y-intercept, and it kind of is in the middle of your screen, then it's a pretty good window. Now let's go ahead and do y equals 3/4 x minus 3. Same idea. You can go back to y equals. Let's say you wanted to look at them at the same time. Then you can just go down to y2. So we have 3/4 times x minus 3. And I'm going to press graph. I think the window is going to work for either one. Notice that those 2 points, or those 2 lines, intersect because they had the same y-intercept, so they intersect there at that point. All right, so that's our review of all things linear, and here's our assignment. I went through and looked at it to make sure that this is what we needed, because I like to try to cut out any extra fluff, but I really felt like it was a good idea for us to keep each of these problems because we touch on a lot of different things and we need a little bit of practice on everything. There are a couple of evens in here, So just remind me in class, and I can read off the answers to evens if you are curious. There's some in here as well. I think those are just matching, so it'll just be real quick for me to read off those answers to you. Okay, thanks everybody. Have a wonderful day.